Okay, welcome back. Now we're going to do the proof of the mean value theorem for integrals. So let's start by saying let f of x be a continuous function over the closed interval ab. Okay? Then, by the extreme value theorem, there has to exist a minimum or maximum on the closed interval. So then by the extreme value theorem, there exists m and m. Let me write it this way. A max, a minimum. A minimum m and a maximum capital M in the closed interval AB. Which means, so that means, so hence, for all x in the closed interval AB, m is less than or equal to f of x, which is less than or equal to m, right? Then, by the comparison theorem, number 3, what do we have? Well, we know that m times b minus a, so this area is going to be less than or equal to f of x, the integral from a to b dx is going to be less than or equal to capital M times b minus a. For all x in the closed intervals. Okay, so what is this? So where are we going? Remember, this is the mean value theorem for integrals. So far, what do we got? We've got this area, right, of this rectangle, and this area of this bigger rectangle, and we know that the area of the function has to be between those two for the entire, or equal to, for the entire closed interval. So let's divide both sides by b minus a. Let me do it differently. So if we divide both sides by b minus a, we obtain m is less than or equal to 1 over b minus a times the integral from a to b of f of x dx is less than or equal to capital M. Okay. Now, since this is a number between m and m, so since this is a number, right, this is the average value of a function, right? So this is a number that's between m, lowercase m, and capital M. And since f of x is continuous and assumes the values m and m over a comma b, by the intermediate value theorem, right? So here's where the intermediate value theorem comes in. For numbers, for real numbers, right? For functions, right? Okay? So let's write this out. So since one over b minus a times the integral from a to b of f of x dx is a real number, or just a number, is a number between m and m, and since f of x is continuous, oops, over the closed interval a comma b, right? Oh, and f of x assumes the values of lowercase m and capital M over the closed interval a comma b. By the intermediate value theorem, there is a number c over the interval such that f of c equals this. So if we look at this, f of x is between m and m, right? And this is the average value of the function, which is just a number that's between m and m. And since f of x is continuous over the entire interval and assumes the values of the minimum and maximum, then by the intermediate value theorem, there must exist at least one c in the interval AB such that f of c equals this number, which is 1 over b minus a times the integral from a to b of f of x dx. And that's the end of the proof. Okay? Have a great day.